On August 6, 2025, the James Webb Space Telescope turned its gaze away from distant galaxies and ancient starlight to examine what had been listed innocently enough as a comet, catalogued as 3I. It was supposed to be routine, a mere interstellar wanderer gliding through our solar system. But what Webb found instead left even the most skeptical scientists shaken. In place of the familiar fingerprints of ice, water vapor, and dust, the telescope detected something far stranger. A torrent of carbon dioxide unlike anything seen before. Peculiar metallic lines etched into the spectrum, and, most unsettling of all, patterns of light so structured, so deliberate, that they could not be dismissed as random noise. This was not a simple comet drifting along an unthinking orbit. It was emitting, steering, behaving like no celestial object ever recorded. And in the days and weeks that followed, as data began to leak and whispers spread through research centers, the realization began to dawn. This wasn't just a discovery. It was a bombshell. If you're new here and you want to stay ahead of the revelations as they unfold, make sure you subscribe now. Every fragment of this mystery is being pieced together in real time. And what's coming may change everything we think we know about life, intelligence, and our place in the universe. The leak that began to unravel the silence didn't arrive with a press conference or a glossy NASA announcement. It began instead with murmurs, internal chat messages, hastily written notes, late-night whispers in secure labs. At 21:11 UTC on August 6, 2025, the James Webb Space Telescope quietly logged an unusual set of spectra with its NIR-spec instrument. On first glance, it looked routine, faint emissions from gas, a soft glow of dust. But a junior analyst at NASA's Goddard Space Flight Center noticed something that didn't belong. Within the baseline readings were structured alignments, repeated waveforms too precise to be thermal noise. They weren't random. They weren't messy. They were clean. Someone, it seemed, had written in the sky. The first warning was just a handwritten note in a calibration log. Signal-like emissions. Possible artifact. That phrase alone was enough to trigger private discussions linking Baltimore, Pasadena, and the European Space Agency's offices in Darmstadt. Was Webb's detector being fooled by cosmic rays? Or had it glimpsed something no comet should produce? At first, the leak was small, like water creeping through cracks. Internal PDFs circulated quietly across astrophysics networks from MIT to Cambridge to Caltech. Amateur sleuths on the internet began to pick at the raw JWST data archives, noticing odd whispers of consistency and symmetry in the noise. NASA's public servers remained clean, bland, unremarkable. Yet the same phrase kept surfacing from back channels, repeating, structured, deliberate. NASA responded as it always does, with a firewall of denial. A statement released on August 8, 2025, downplayed the anomaly as likely a calibration error or a cosmic ray glitch. But inside, urgency was rising. Teams tasked with reproducing the error couldn't erase it. Every dataset returned the same result. The anomaly was stubborn. It wasn't fading, and the realization began to harden. Webb hadn't just observed a comet. It had listened to something, and that something had spoken back. What began as denial soon morphed into obsession. The anomaly spread like fire through the scientific community. It wasn't just about unusual chemistry anymore. It carried symmetry, consistency, and an almost musical rhythm. To understand what Webb had truly seen, one must return to that precise moment on August 6th, when the telescope locked onto 3I and revealed not ice and dust, but chaos hidden beneath a masquerade of gas. On that day, the James Webb Space Telescope targeted 3I with its NIR-spec instrument, producing some of the most detailed cometary spectra ever recorded. The coma, the hazy atmosphere surrounding the nucleus, wasn't dominated by H2O as expected. Instead, carbon dioxide drowned out the spectrum almost completely, with a measured mixing ratio of approximately 8.0 plus 1.0. This was one of the highest CO2 to water ratios ever detected in any celestial body. Typically, comets beyond 5 astronomical units from the Sun are dormant, releasing only faint traces of water vapor. But 3I, still 6 astronomical units away, was explosively active. Its CO2 jets erupted preferentially on its sunward hemisphere, indicating directional emission, as though the gas was being focused rather than sublimating naturally from a uniform icy crust. This wasn't passive physics. It looked controlled. Ground-based observatories, like the Very Large Telescope, confirmed Webb's findings, strengthening the anomaly with independent datasets. Traces of water ice, carbon monoxide, and other compounds were buried deep in the noise, dwarfed by the overwhelming presence of CO2. Even compared to 2I Borisov in 2019 or the enigmatic Oumuamua in 2017, 3I was rewriting the book of cometary science. Its nucleus appeared intrinsically CO2-rich, with suppressed water sublimation like an alien fingerprint etched into gas. Some whispered that this composition could cloak an internal structure, a shell enriched in CO2 masking something beneath. To the naked eye, it was a comet. But to Webb's instruments, it was something else entirely. A masquerade built on carbon dioxide. The chemical chaos was only the beginning. Astronomers could rationalize a high CO2 comet with exotic birthplaces or unusual ice chemistry. But Webb's spectra from August 6th carried something far more explosive: structured light emissions. Not just gas sublimating into space, but brightness pulsing in repeating cycles, wavelengths stacked with intent. Analysts began scribbling phrases like photonic systems and internal energy in the raw logs. This was no longer about unusual chemistry. This was about whether 3I was broadcasting. The first leaked memo used a word rarely seen in astrophysics: beacon. Webb's spectra showed repeating patterns in the infrared bands, with peaks aligning at intervals no natural process could mimic. Instead of random scatter, the light curved into modulation cycles, repeating every 11.2 seconds, a signal analysts familiar with interstellar communication protocols found chilling. This wasn't a comet glowing, it was a system emitting. What stunned the review team even further was the brightness source. Normally, comets reflect sunlight. Their spectra are a blend of scattered starlight and gas fluorescence. But Webb's data pointed inward. The luminosity didn't match external reflection. It originated from the nucleus itself. A heat map at 426 microns revealed a central energy source radiating outward, surrounded by a symmetrical CO2 halo. A natural body this small should be inert. Instead, 3I glowed like a lantern in deep space. Reports described the CO2 halo as perfectly symmetric, extending hundreds of thousands of kilometers into space. Unlike the ragged, chaotic outflows of normal comets, 3I's halo was neat, concentric, controlled. Scientists whispered about containment fields, pressure envelopes, or artificial structuring of gas. It was as though the CO2 wasn't escaping randomly, but being arranged, sculpted into form. The term self-shading emerged in leaked documents, a placeholder for phenomena with no existing vocabulary. Together, these findings formed a bombshell, a body approximately 46 kilometers across, venting carbon dioxide in engineered symmetry, glowing from within, and emitting signals structured like prime number sequences. No calibration error could conjure this. No ordinary comet could hide it. 3I was more than a fragment of ice and rock. It was behaving like technology. Once you see the structure, you can't unsee it. The emissions weren't just strange. They suggested intent, a beacon, a light pulsing as though alive. With each new leak, the object shifted from icy visitor to engineered enigma. But Webb's revelations weren't confined to spectra alone. Observers began asking a deeper question. What shape is 3I, and what does it hide beneath its luminous skin? Early estimates had placed its diameter at 10 to 15 kilometers based on brightness curves. But by late August 2025, internal Webb analyses suggested the nucleus could be as large as 46 kilometers across. That would make it more than twice the size of Hale-Bopp in 1997 and the largest interstellar object ever identified. The odds of such a massive fragment entering our solar system by chance were nearly zero, yet here it was. More unsettling still was the geometry of its coma. The CO2 halo, confirmed independently by the Very Large Telescope, stretched hundreds of thousands of kilometers into space, but it wasn't ragged. It appeared nearly spherical, symmetrical in a way reminiscent of engineered containment fields rather than chaotic ice sublimation. Natural comets exhibit uneven jets, irregular outbursts, and asymmetric plumes. 3I looked curated. Then came the shadow anomaly. Infrared mapping revealed a linear dark band cast across the halo, maintaining its shape regardless of solar angle. Normally, comet shadows stretch and distort depending on the light source. 3I's band did not. Analysts coined the term self-shading. This implied not only that the body might be generating its own shadow, but also that some geometry, internal or external, was actively controlling it. The findings pointed toward hidden structure. Was 3i hollow, a shell cloaked in CO2? Did it carry an internal framework, a scaffolding of some engineered design? Some at Caltech suggested cloaking geometry, an artificial mask wrapped in comet gas. If so, 3i wasn't just big, it was deliberate.